Hey guys, today we'll be talking about root test, something we have not discussed in our previous videos. So the question is, does this converge? So if we were to use the ratio test, that would be our instinct as we see power and n is raised to the whole thing. So that would be our instinct. But if we were to use the ratio test, things get really messy. So let's say we use the ratio test, limit n tends to infinity, a n+1. So yeah, let's remove the negative sign since it's a modulus. n+1, again n+1 plus 1, 5n times 2n+1 n+2 to the power 5. I use the laws of indices because if you have 5n plus 5 in the power, if you have something like this, then you can write it as this, right? So that's what I did. But if you were to do this, you don't know what cancels what. Things get really messy. So that's an ineffective way to go around this problem. So there is another test. There are a lot of tests when it comes to sequence and series. So the other test is the root test. So what the root test tells us is if the reason it's called the root test is because we have a root sign, under root sign is equal to p, and p is less than 1, then the series is convergent. If it is greater than 1, divergent. If it is equal to 1, then the test fails. We have no conclusion. So let's apply this for this question. It's a very easy one, just an example to get things started. So let's do it quickly. Limit n tends to infinity. So an here would be 2n over n+1. I got rid of the negative sign because we have a modulus. And remember, it's not a square root, it's nth root. Okay? Yeah, I got rid of this negative sign. Oops, not what I meant to do. Rid of this negative sign because we have a modulus. See? Right over here. Okay, so is equal to limit n tends to infinity 2n n+1. You can express the root as times 1 over n, just like how root 3 can be written as 3 to the power 1 over 2, right? So the n over here in the denominator cancels the numerator, so you get limit n tends to infinity 2n n+1 to the power 5. So now you can use the L'Hopital rule or whatever you want, but I think the easiest way is to divide both the numerator and denominator by n. So what I'm saying is you can do 2n over n n+1 over n. You can do this because these things cancel each other regardless. So limit n tends to infinity, the n over here cancels this n, and if you split the denominator, then what you have is n over n plus 1 over n, right? N over n, it's 1. So what you can write is 2 over 1 plus 1 over n, when n tends to infinity, is 0. Plus 1 plus 0, you don't need to do that. So basically it's this, right? And is equal to, since you already added the value of n, you should be removing this. is equal to 2 to the power 5 is equal to 32. And since 32 is greater than 1, the series, does it converge? No, it diverges. So it's very simple. I chose a very basic example to get started. I hope you understood it, nothing very difficult.